Hello everybody and welcome to another mystery box function challenge. In the purple mystery box there is some math and your challenge is to figure out what it is. Because today is a Friday, that math is going to be particularly challenging. If you'd like to use the link in the description, you can try this out on your own, and when you've got an idea, come on back and see if we get the same thing. All right, let's try it with a 0. Okay, 0 gives us 1. How about a 1? 1 gives us 2. All right, how about a 2? Okay, so 2 gives us 2.665. Yeah, that looks like a non-repeating decimal. So I'm wondering if this is a square root function. How about a 3? And that looks like another non-repeating decimal. Okay, how about a 4? 4 gives us just plain old 4. Okay, that's interesting. You know, the shape of this is a little odd for a square root function. You can see that it curves a little bit, but then starts to look like it's becoming more of a straight line. Let's go out a little further. Let's do 6. And let's do 8. And all of those, yeah, all of those are non-repeating decimals. Let's just put in a 9. And that gives us a whole number. All right, maybe the whole number answers are going to be clues here. Boy, this is a strange one. It really does just look like a straight line, doesn't it? Except closer to 0. Let's look at 1/2. Yeah, you can see the hump of that curve before it sort of straightens out. And let's try some negative values, see what it's doing over there. Oh, okay, so that lends more credence to the idea that this is a square root function. So we're getting not a number. Let's just try -9. All right, so it appears not to be defined for any of the negative values. So that is definitely making me think of the square root of x. So that probably has something to do with this. The non-repeating decimals make that likely, and also getting the whole numbers for certain things. I mean, that's how the square root function would look. You get whole numbers at 1 and 4 and 9. Oh, and look at this. We've got, yeah, whole numbers at 0, 1, 4, and 9. So that speaks to the square root. But this is not the shape of a square root function that I've ever seen before. I guess it looks a little bit like it right here. So what is going on here? So, you know, if this is the square root function, the square root of 0, how do you get 1 out of the square root of 0? I suppose you could add 1. And then if you did the square root of 1 and you added 1, you'd get 2, so that makes sense. But the square root of 4, if you added 1, you would not get 4, you'd get 3. And here you would get 4, and we're getting 8. Huh, okay. So ignoring the non-repeating decimal pieces, just look at these numbers, 1, 2, 4, 8. If I had gotten those as, you know, the output of successive numbers in a function, I would think exponential, like 2. So, you know, this is 2 to the 0 power. This is 2 to the first power. This is 2 to the second power. Oh my goodness. Okay, I think this might be it. Look at what we've done. If you take this number and you take the square root of it and then raise 2 to that power, yeah. So the square root of 4 is 2. You raise 2 to the second power, you get 4. The square root of 1 is 1. 2 to the first power is 1. So I guess this function would look like f of x equals 2. Yeah, to the square root of x. And that would make sense that it wouldn't be defined for any negative values, because you put that in here in your exponent, and the first thing you do is take the square root, and that's going to give you not a number. And the rest of this, it does look like it works. I mean, are these decimals, are they looking right? So if we put in, for example, a 2 to the square root of 2, approximately what would that be? Well, 2 to the 1.4 something, right? And you know, that would be a little over 2. and we've got 2.6, so I guess that fits. Let's think about one more value. Let's do 6. So 2 to the square, well, that's not an easy one, but 2 to the square root of 6. So what would the square root of 6 be? Well, it's somewhere between the square root of 4 and the square root of 9, so it's somewhere between 2 and 3. So we're taking 2 to the 2 point something, and that should be, yeah, it's going to be a little over 4, and here we've got the 5.46. I think this has got to be it. It's the only thing that seems to work with all of our easy values, and I think it works with these more difficult values as well. So I think I'm going to take a look at this one and see if we're on the right track. There we go, 2 to the square root of x. So interesting that it makes basically a straight line. And let's graph that as well. Yeah, so you can see the kind of little bit of this tapering curve here, and then it definitely straightens on out as we go higher. Well, how did that go for you? I think that was super difficult. Were you thinking square root? Were you thinking exponential? Let me know. Thanks, everybody.